Okay, once again, thank you for your timely arrival at our regular Friday meeting of environmental science. We have today's activities lined up on the board. Midterm coming up next week. Please note that we have a study guide that will be handed out at the end of class today, so make sure that you get out with your study guide. That's going to be helpful in studying for the midterm. And also we'll be using the regular quizzes that we've had as a part of that study guide as well. So make sure that everybody has all the materials that they need in order to go after next week's midterm. Quiz 3 today on chapters 3, 4, and 5. We had the PowerPoint and lecture on that last week. Hopefully everybody had a chance to go back and review and go through that. But we'll do a quick review here before we get started so we can get that kind of repetitive activity. We want to use all of our learning modes and store in that long-term memory storage. Chapter 3, folks, had kind of that chemistry lesson that a lot of folks had trouble with. Thermodynamics, remember? And ideas that we want to express in thermodynamics. Thermodynamics, the study of energy, movement of energy. And we see that energy exists in two forms, potential and kinetic energy. See in your textbook the graphic of the fellow with the bow that demonstrates the energy of rest and the energy of motion. So potential energy, just like the term explains, potential energy is energy that may happen, that is being stored.
Is that that bow and arrow?
That's when the bow is cocked and ready to shoot, the energy from the recurve bow is stored in the arrow, it's ready to go, but it doesn't have movement. So it's potential. Kinetic energy, the other form of energy, is the energy of motion. Kinesis means to move. So the second part of that illustration shows the person letting go of the arrow, and then as it shoots out towards its target, the energy becomes kinetic energy. And natural systems have these same storage methods that allows energy to move around through the ecosystem. So examples of potential and kinetic energy, how about the energy in plants? Potential or kinetic energy? We're going to get our food from eating potential energy, exactly right. Chemical energy is stored in those bonds. Photosynthesis allows the plant to put together these simple sugars, and so it stores potential energy in the chemical bonds. Our digestive system then, by breaking those bonds and doing the respiratory cell process, is going to use that energy and circulate it around in our body. Kinetic energy then is when that is used by the cell and used to make protein substances in the ribosomes. And this transformation of kinetic and potential energy is how we're able to use energy in the ecosystem. But natural settings are an open system. There's always loss to friction and heat. Human beings, of course, try to design systems that are closed systems. The internal combustion engine, we try to catch every bit of power. New hybrids even catch power from the brakes, the friction of the brakes, but very difficult to have a completely closed system, as we see in the laws of thermodynamics. First and second laws of thermodynamics. Remember this stuff? Mm-hmm. What's the first law of thermodynamics? Energy can neither be created or destroyed. We think of ourselves as human beings as being able to create energy because we have technology. We get electricity. But in fact, these are just transformations of energy that exist in another form.